So we are going to revise the chapter, starting with the first chapter, Thermodynamics. And as you will be aware, thermodynamics is the study of heat energy, how heat energy is linked with matter and all those things. So let us start. So since thermodynamics deals with heat, we are first learning how the temperature is measured. So first of all, what is meant by temperature? Or let me see, what is meant by temperature? Temperature is the thermal state of a body that determines whether a body can give out heat or receive heat from another body. So temperature is just the state of heat in our body. So it's a state of a body, and that determines whether a body can give out heat or receive heat from another body. For example, now it is very cold in Bahrain. So when we move out, our body is at a higher temperature than outside. So what happens? The temperature from our body go out. We can give out heat to the surroundings. Now, if we are going to a very hot place, then what happens? The surroundings are hotter than our body. The surroundings have higher temperature than our body. So what happens? Our body gets heated up, which means our body receive heat from the surroundings. So temperature is a comparative statement, and it is the thermal state of a body that determines whether a body can give out heat or receive heat from another body. Now, what is meant by thermal equilibrium? You will definitely have some idea about thermal equilibrium. What is it? What happens when we put some ice in a glass of water at normal temperature?
The ice melts.
Ice melts, and what happens to the water?
It turns cold. The water turns cold.
Yeah, the water turns cold, which means the water's temperature decreases. Initially, let us suppose the temperature of the ice is 0 degrees Celsius. Now, when we take water, suppose it is 40 degrees Celsius. If it was equal amount of ice and water, after some time, what happens? Ice melt, which means the temperature of the ice increases from 0 and water cools down. So the temperature of the water decreases from 40 degrees Celsius until they become equal. Suppose both of them become some 20 degrees Celsius, then their temperatures are equal. So this state is called thermal equilibrium. If different parts of a system are at same temperature with the environment, and if there is no exchange of heat between them, then the system is said to be in thermal equilibrium with the environment. So once all ice melts in water and the water and the ice becomes of the same temperature, will there be any exchange of further heat? No, there will be no further exchange of heat. So when we bring a hot body and a cold body together, heat will go from the hot body to cold body until their temperatures become equal. Now we can see that these two bodies are in thermal equilibrium. So different parts of the system are at the same temperature with the environment or with the surroundings, and there is no exchange of heat between them. Then we say that these two blocks are in thermal equilibrium. Is this clear to you? Is this clear to you?
Yes, teacher.
Now, how can we measure temperature? The instrument by which temperature of a body and the difference of temperatures of different bodies can determine is called thermometer. So we use a thermometer, which is the instrument by which temperatures can be measured. Now, how will we measure the temperature using a thermometer? For that, there are specific properties that change uniformly with temperature. For example, some gases, when they are heated, they expand or their volume increases. And certain gases, this volume increase or change in volume is uniform. So sometimes the volume of the gas will expand or increase uniformly with temperature. So such properties like volume and sometimes the resistance of certain materials, if you increase the temperature, the resistance increases. And sometimes the relation between temperature and resistance is such a way that we can use resistance as a property with which we can measure the temperature. So specific properties of substance, it can be resistance, volume, pressure, so that change uniformly with temperature, and observing those properties, we can measure accurately the temperature. Those properties are called thermometric property. And the material using whose thermometric property a thermometer is constructed is known as thermometric substance. For example, when we take mercury thermometer, mercury is the thermometric substance, and it's the volume of the mercury increasing when we increase the temperature. So we can either tell the volume of the mercury is the thermometric property. Is that clear to you? What is thermometric substance and thermometric property? If it is so, let us see some of the thermometric properties and the thermometers that use. Volume expansion of gas is used in gas thermometers. Volume expansion of liquid like mercury is used in the laboratory thermometers, clinical thermometers, etc. And volume expansion of solid is used in bimetallic strip thermometers. There will be two metal strips, each one will expand in a different way with temperature. Then pressure change of fixed mass of gas. So constant volume gas thermometer. Then changes in EMF of a thermocouple. So the thermometer which uses this property is called thermocouple. And changes in electrical resistance of certain materials. The thermometers that use this property is resistant thermometer or thermistor. So let us see some of the thermometers. Which of this you are familiar with? Can you tell me? Out of this, which one you have used? Have you used this one?
No, teacher.
You haven't used this one when you have
Liquid
fever?
in glass
Temperature, that one.
Have you used? Someone told something.
Yeah, that one, second one.
Yeah, liquid in glass sometimes to find uh, temperature when you are sick, or you may be now using this one digital. It has a thermistor.
Yeah, teacher.
To check the temperature when you are having fever. Has a thermistor that reacts to change in temperature and projects the result on the thermometer screen. Now, have any one of you not seen this one?
Yes, we've seen this in when
Where?
we entered the mall.
When you enter any mall, anywhere. Even now, when you enter the school, we are using.
In our school also.
Yeah. So due to COVID, now it's very important we check the temperature of every person when they enter the office. So we are using this now everywhere. They are using this. See, infrared use thermal radiation that objects emits to measure temperature. So our body emits infrared radiations, and the amount of infrared radiation emitted depends upon the temperature of our body. So even without touching us, we can use this infrared thermometers to measure the temperature. Now this is an example for a bimetal, a mechanic type that works with a bimetal strip. The strip is sensitive to change in temperature and it causes mechanical displacement, means it makes the needle move, which is used to determine the temperature. And gas, see, there is a tube here where there is gas, and the difference in pressure or volume of gas fitted with it is used to measure the temperature. So this is manometric. Manometers means pressure filled vapor. So it contains another tube which is filled with some air at a low pressure, and as the temperature changes, the pressure changes, which is used to find the temperature. So these are different types of thermometers. Now I will go a little bit faster looking at the textbook so that the topics can be covered at a faster rate. So we were discussing about thermal equilibrium, how temperatures are measured using different kinds of thermometers. Now, when we fix the scale of a temperature, we use two fixed points. What are they? The lower fixed
And
point,
low.
yes, and the upper fixed point. What is meant by lower fixed point? At standard pressure. What is standard pressure? 1 atmosphere pressure is called standard pressure. That is 72 millimeter of mercury. That is called standard pressure. And at standard pressure, the temperature at which pure ice remains in equilibrium with water. That is, the temperature at which pure ice begins to melt is known as lower fixed point or ice point. You can tell that at standard pressure, the temperature at which pure ice begins to melt, that is called lower fixed point. What is that temperature in degrees Celsius? Do you know how much is the temperature in degrees Celsius? It is 0 degrees Celsius.
0.
Yes. So ice just starts melts at 0 degrees Celsius. So that is the lower fixed point. Now, what is meant by upper fixed point? The standard pressure at which pure water begins to become water vapor. That the pure water begins to boil or becomes water vapor is called the upper fixed point. What is the boiling point of water?
100.
100 degrees Celsius. So in Celsius scale, you can say that the lower fixed point is 0 degrees Celsius and the higher upper fixed point is 100 degrees Celsius. But if you are asked to define lower fixed point, you have to tell that it's the at standard pressure, that is 1 atmospheric pressure, the temperature at which pure ice begins to melt. And what is upper fixed point? At standard pressure, the temperature at which pure water begins to become water vapor. So these are the two fixed points which are required when we are determining the scale of temperature. There are different scales of temperature. Which ones do you recall? Different scales of temperature. One is the Celsius scale, that is what we are calling degree Celsius. Second one is the
Fahrenheit.
Fahrenheit.
Fahrenheit scale. And the third one is,
Kelvin scale.
yeah, the third one is Kelvin scale. So these are three of the scales. So when we are determining the scale, we have to know what is the lower fixed point and what are the upper fixed point. Now, when you know the thermometric property, how to calculate the temperature, that is using this equation. What is theta? Theta is the temperature of a body. Usually we express as theta when it is given in degree Celsius, in Celsius scale. And if it is in Kelvin scale, we usually express temperature by capital T. Here we are taking a general case. In any scale, suppose theta represents the temperature of a body And theta ice represents the ice point, that is the lower fixed point of at that scale. Now, theta steam represents the upper fixed point, which is also called the steam point. So, theta minus theta ice divided by theta steam minus theta ice will give you x theta. X theta represents the thermometric property of the substance at theta temperature. For example, if it is the length of a mercury column, it's the we are trying to take a temperature. Suppose it is 30 degrees Celsius. Then theta will be 30 degrees Celsius. Then x will be the length of that mercury column at 30 degrees Celsius. And x size will be the length of the length of the mercury column at ice point, which is at 0 degrees Celsius. And x steam will be the length of the mercury column at steam point, which is 100 degrees Celsius. So if you substitute these value, you can calculate any of the unknown temperature. Now, the distance or the difference between the steam point and ice point is called N. That is called the fixed interval or the fundamental interval. The interval between the upper fixed point and lower fixed point is known as the fixed interval. You need to memorize this equation. Is it clear to you what each one stands for? Is it clear to you?
Yes, teacher.
Okay, so they have, as I told before, if we are taking the Celsius scale, uh, ice point is 0 and steam point is 100 and the fundamental interval will be 100. So theta minus 0 divided by 100 is equal to x theta minus x ice divided by x steam minus x ice. So if you want to find theta, theta minus 0 is theta. Taking 100 to other side, you can use this equation. Now, this will be a constant for any scale. So this is for Celsius scale. Ice point is 0 and steam point is 100. Now, let us see what is the case for a Fahrenheit scale. For Fahrenheit scale, the ice point is 32 degree Fahrenheit, which means they have considered not the ice, but something which can exist below 0 degrees Celsius. Like they considered the lowest temperature as the mixture of equal amount of ice and ammonium chloride, which has a temperature which is less than the melting ice. So that is taken as the 0th point or the beginning point in a Fahrenheit. So 0 degrees Celsius is equivalent to 32 degree Fahrenheit. Similarly, the steam point is 212 degree Fahrenheit. So the fixed or fundamental interval N will be equal to 180. So we substitute those values in the equation and then we will get that theta minus 32 because 32 degrees Celsius is the point at which pure ice, degree Fahrenheit is the point at which pure ice starts to melt. And 180 degree is the interval. And 212 degree Fahrenheit is the upper fixed point for Fahrenheit. So remember these values because they may be asked for multiple choice. What is the lower fixed point in Fahrenheit? 32. And what is the upper fixed point in Fahrenheit? 212. And what is the fundamental interval? It's 180 degree. So you can substitute in this value for Fahrenheit scale. Now, in a mercury thermometer, as we discussed before, the thermometric property is the length of the mercury column. So they have expressed instead of X, L, length of the mercury column, and length of the mercury column at a temperature theta minus length of the mercury column at 0 degrees Celsius or ice point, and divided by length of the mercury column at 100 degrees Celsius or steam point minus the length of the mercury column at ice point into 100. So this is how when we can consider the thermometric property. Sometimes it will be resistance, sometimes it will be the EMF. So whatever be the value. So resistance thermometer, instead of length, they have taken resistance. That's all. So now let us consider clinical thermometer. What is meant by clinical thermometer? The thermometers which we use to check human temperature, to check whether there is fever or not. So in a clinical thermometer, can you measure 50 degree Fahrenheit? Say yes or no. Can you measure 50 degree Fahrenheit in clinical thermometer? No, because in clinical thermometer, you can measure only from 95 degree Fahrenheit to 110 degree Fahrenheit. Why? Because the temperature of human body varies from 95 degree Fahrenheit to 110 degree Fahrenheit. So it is calibrated so that it can measure only between these two temperatures. So that is an important question. They will ask you why you cannot measure 50 degree Fahrenheit in a clinical thermometer. Then you have to tell that since the temperature of human body varies from 95 degree Fahrenheit to 110 degree Fahrenheit, the thermometer is calibrated from 95 degree Fahrenheit to 110 degree Fahrenheit. And one more thing, remember the temperatures, human body temperatures are measured in Fahrenheit. Sometimes we ask, what is the temperature when you have fever? It's 101. Does that mean 100 degrees Celsius? No way. It will be only 101 Fahrenheit. So it's not same as degrees Celsius. So don't get panic when we hear 100 degree is the temperature of a human body. So it's usually measured in Fahrenheit, the clinical thermometer. Now, there are certain thermometers which are based on one fixed point. What we discussed before, like clinical thermometer, which use Fahrenheit scale, and also the laboratory thermometers, which use degree Celsius scale. They are all based on two fixed points. But there are certain scales of temperatures which are dependent on one fixed point. Kelvin scale of temperature is an example for a scale of temperature that depends on one fixed point. So let us see how it works. Some of the properties which are expressed by X is directly proportional to temperature. As we change that property, the temperature also changes. So they are directly proportional to each other. So you can express X is equal to a constant A into T, or T equal to a constant B into X. So the temperature can be expressed as based on one fixed point. So this constant B is equal to T by X. This is a constant. So the temperature divided by that thermometric property will be a constant. So temperature Tp means temperature at a fixed point divided by thermometric property X at a fixed point. So it will be a constant. T by X will be a constant. So if you know T by x is a constant, then you can write T by x is equal to Tp by Tx, or T is equal to Tp by xp into x. So what is meant by that fixed point? That fixed point is called the triple point. At a definite pressure, the temperature at which solid, liquid, and gaseous state of a substance coexist in thermal equilibrium is called the triple point of that substance. Can you tell that at atmospheric pressure, can ice, water, and water vapor coexist? Have you ever seen ice, water, and water vapor coexisting at usual temperature, atmospheric pressure? Have any one
No.
of you seen? No, it's not possible, right? But it is possible at very low pressure. See, at pressures like 4.758 millimeter mercury. What is atmospheric pressure? What is atmospheric pressure? I hope you have learned atmospheric pressure. What is atmospheric pressure? Is it more or less than 4.58? What is atmospheric pressure? Atmospheric pressure is 760 millimeter of mercury. See, this is very low compared to that. So the usual pressure around us is 760 millimeter of mercury. So at very low pressure compared to that, there is a situation where solid, that is ice, liquid, that is water, and water vapor, which is gas, coexist in thermal equilibrium. This is called the triple point of that substance. So triple point of water is at 4.58 millimeter mercury pressure. I want to focus on this because you will wonder at what point they will coexist. It's at a pressure which is very low compared to the atmospheric pressure. And at this pressure, the temperature at which pure ice, water, and water vapor coexist in thermal equilibrium is known as the triple point of water. And what is the value? It's 273.16 Kelvin. So you have to remember the definition of triple point of water and also its value. It's 273.16 Kelvin, and K means Kelvin in SI unit of temperature. Now, what is 1 Kelvin? It's the SI unit of temperature, and 1 Kelvin equal to 1 by 273.16 of the triple point temperature of water. Now, it's also 0 Kelvin is called the absolute zero temperature. Why is it called absolute zero temperature? Absolute zero means nothing is moving. It's an ideal concept. No body ever exists in absolute zero temperature. That is the lowest possible temperature any material can have. That's why it is called the absolute zero temperature. Even in Kelvin scale, the ice point, that 0 degree, is 273.15 Kelvin. And steep point is plus 100, that is 373.15 Kelvin. So in one fixed point scale, you can express temperature as equal to 273.16 Kelvin. That is the constant B into X by X temperature, means X is the thermometric property. And XTR is the thermometric property of the thermometric substance at triple point. You know how to convert degrees Celsius to Kelvin? Do you know
Yes,
how
teacher.
to? Yeah, how?
There is one equation.
Yeah, how to convert Kelvin means degree Celsius plus 273.15. So if it is 0 degrees Celsius, in Kelvin scale, it is 273.15 Kelvin. Okay. Or for simplicity of calculation, you just keep 273 Kelvin. So what will be 100 degrees Celsius? 100 plus 273.
373.
That is 373 Kelvin. What will be 200 degrees Celsius? Tell it fast.
473.
Huh?
473.
Yeah, 473 like that. You just have to add with 273, then you will get the temperature in Kelvin. So this is absolute scale of temperature. As I told, the substances are not moving at all in absolute scale of temperature. It's also called the international scale of temperature, or that is the SI unit of temperature. Now,
Yes.
there are some fixed points. I think the time is going to get over. So we will just discuss this one and we will end. So you can learn this formula to convert different temperature scales. If you want to convert degrees Celsius to Fahrenheit, you can use this one. C means temperature in degrees Celsius. F means temperature in Fahrenheit. So C by 5 is equal to F minus 32 by 9. And to convert Fahrenheit to Kelvin, you can use these two. That is F minus 32 by 9 is equal to Kelvin minus 273 by 5. So you have to know how to convert different scales of temperature. So I'll stop it now.